turn the light off in front. That's it. All right. Advil. This one don't do. Already. Yeah, don't have a calibrator. Where'd that come from? All right. Let's pull up and let's see what y'all are doing in 5.6. Okay, where is, there it is. Let's see if I want to go over anything before I go over 5.6. Well, let me ask y'all, when did you have 101?
Fall of last year.
Fall of last year. What about you? Or 101 or Algebra 1 or?
It's fall 2014.
Last year?
Last year, yeah.
The only other math I've had is problem stuff.
Okay, so you haven't had Algebra 1 since high school?
Same. I've been at it from
What about you?
high school a couple years ago.
Since high school, fall last year.
Since high school, I've taken problem stuff.
Okay, so we might need a little bit of review on some previous sections. So, let me look and see where I think I should start. Okay, come on. I want to look and see what's in the book. And I'm going to pick, I have a good idea of where we're going to review and start, but you know, it's probably exponents and a little bit of polynomials and factoring. But I want to check and make sure. It's supposed to give me the introduction factoring. Okay, we're going to do 4, 5. All right. I know what I'm doing, believe it or not. All right, first of all, I want to go over a little bit of Algebra 1 concepts. Because I want to make sure everybody's on the same sheet of music. Some Algebra 1 concepts that we need to review. First of all, your exponential laws. And they are the product rule, and that is x to the n times x to the m. And what you do when you have the same base, let's take our handy dandy highlighter. Oops, that's not right. Dork. It's not doing what I want it to. Somebody's fault. There. Same base, different exponents, and we're multiplying these bases. What do you do to those two exponents?
Yeah.
Add them together. Good job. Okay, I'm going to quit and let y'all come up here and teach. X to the n plus n. Okay. Quotient rule. X to the n over x to the m. Got the same base, and I keep bringing up the same base because some people, if I put x to the 4th over y to the 5th, y'all still try to, you can't do that. The same bases, they have to be the same. What do you do to the exponents?
Subtract.
Subtract, good job. Power rule. X to the n raised to the m power. What do you do to the variable, the exponents when you are multiplying or raising a power to a power?
You multiply.
The inverse rule. The inverse rule is mainly used for negative exponents. Okay, it's for make things look pretty. All right, you only use it with exponents, you do not use it with scientific notation because scientific notation is not negative exponents. Scientific notation is totally different. So inverse rules is just with exponent. And that is if you have x to the negative n over 1, you flip it and it becomes 1 over x to the n. And vice versa. If you have 1 over x to the negative n, you flip it and it becomes x to the n over 1. So inverse rule is kind of like an aesthetic rule. You don't need to use it, but in our culture, a lot of other cultures, they don't care if it's a negative exponent. Some of the Asian cultures, negative exponent ain't no big deal to them. All right? But with us in the U.S., we like to have a positive exponent. So we manipulate the problem to give us a positive exponent. Now there's one more rule. It's another aesthetic rule. And that aesthetic rule is called the inverse power rule. Whatever. I'll forget it. It's the only thing about these boards I don't like is sometimes they'll do what you want them to and sometimes they won't. Inverse power rule is another aesthetic rule. And it's used, again, to get rid of a negative exponent when possible. And that is if you have, and this is parentheses, so it's different. Let's see. Actually, I should take these off. You should take these off. No, this one. You should take these off. Because you don't need it. Come on, please work with me. Can we get any smaller? There. Okay, take those off. Okay, with power rule, and I'm going to put these in red, you're going to have you're going to have parentheses, and you're going to have in the parentheses x to the n over x to the m, and you have it raised to the negative w power, or some negative power. Now, what this does, if you flip what's on the inside of the parentheses, it will make this positive. So the difference between the inverse power rule and the inverse rule is the inverse rule does not have parentheses. The inverse power rule has parentheses, which makes us a difference between a cat and a bobcat. Okay? Which one would you rather cuddle up to at night? A cat. I wouldn't want to cuddle up to a bobcat, but they're both cats. All right? This cat, that's a bobcat. So it's a little bit bigger. It's got different features, meaning that the problem is encompassed with a parenthesis, and it works different from this. So when I flip this inside parentheses, I get x over x to the m over x to the n raised to the w power. Now, could I use the power rule and distribute that w now? Yes. And numbers, they combine. So if this was a 1 and a 2 and this was a 3, then that would be 3 over 6. X to the 3 over x to the 6, and then you could... So this is just a review to kind of get your brain thinking about those Algebra 1 concepts. All right, so we good on that? Good review over that? Then we moved into polynomials. Can't spell either today. Polynomials is an umbrella term. Polynomials mean monomials, binomials, trinomials, and so on. I can't spell today. I don't know what's wrong with me. Maybe I do need some drugs. Monomial, 2x, 1/2 y. 3x to the 0 or 3. Those are all monomials. Binomial, 2x plus 4, x minus 3, 2x plus 7. Those are all binomials. And of course the trinomials are x squared plus 3x plus 2, 4x squared minus 2x plus 7. Dang, I forgot the hand. And of course, a polynomial would be 4 or 5 terms. You call it a 4-term polynomial, 5-term polynomial, 6-term polynomial, and so on. I do not claim to be an artist, so I'll go ahead and get that out now. I suck at drawing, so don't say nothing about my drawings because I know they suck, okay? All right. What kind of problems do we work with in algebra? Well, there's 2 types. There is the equation, and there is the what? Expression. What's the difference between the 2? Anybody want to give me a difference?
Equation is a sentence.
Both of them are sentences. This one's more of an incomplete sentence.
Has a equal equation. Has equal.
Say it.
Equation is equal.
Okay. Okay, now we're going to have to learn to enunciate and speak loud. Okay? Do y'all want me? I'm not picking on you. Do y'all want me?
No.
Okay. Then I don't want that from you. Enunciate. I don't want to hear. You're right. Equal sign. Then that means the expression does not what?
Equal sign.
Does not have an equal sign. Now when you see an equation, the word that starts with an S that goes with equation is solve. The word that goes with expression that starts with an S is what?
Solution.
Simplify.
Simplify. The equation, you're cutting the meat to eat. In other words, after you cook the steak, you cut into it. Steak is my favorite. That's why I raise beef cattle. All right? You cut it, you're ready to eat it. All right? What are you doing over here?
Trimming it.
Trimming fat before you cook it. Okay? So you're trying to get rid of all the extra stuff that you don't need. Think of it as I don't know. Think of it as you're going on a diet and you order a meal and you cut all the stuff that you can't eat. You cut out the dessert. You cut out the sweet tea. You drink water instead of sweet tea. You cut out the fat around the piece of meat that you're eating. You cut out the French fries and put in a baked potato with very little sour cream or very little butter. Or put a salad in there, or what? In other words, you're simplifying it. You're cutting it down. Here's when you solve it and you get an answer. You cut into the meat. All right. So there's the 2 types of equations and expressions. Now, we also got something else in here in algebra, and I'm going to put it separate because some of y'all get confused on this because I used to. There, now can I move you? There. I have a third. And do y'all know what the third thing is called? And it's totally different. Graphing. And that's totally different than these 2. In other words, this is more of a physical drawing. Okay, this is physical drawing stuff. In other words, I'll get into that later with you. I don't have to review this because I'm going to review it when I get into graphing later. Okay, so we don't need to worry about this right now. Okay, so in algebra you got three categories. You got equation, you got expression, and you got graphing. We're not going to worry about graphing while we're talking about chapter 5 and 6. Okay. So, what else is there in algebra? Well, there's 4 operations. What are the 4 operations?
Addition, subtraction, multiplication, and division.
There you go. This right here is called distributive law, or F-O-I-L. I do not pronounce F-O-I-L, and I do not pronounce F-O-I-L. I spell it. Why do I spell it? Because when you say those 2 words, people either think you're a dumb, ignorant Southerner because you say it without the I, or you sound like a Pennsylvania nasal clerk. And you pronounce the I, the O-I, very predominantly. So I don't pronounce either because I don't want anybody making fun of me. So I say F-O-I-L and O-I-L. This is factoring. And this is just combining. Somebody might have not have told you that when you made the transfer over from pre-algebra to algebra and started adding and subtracting, and they started saying, okay, now you got to distribute this, and you got to do this, and you got to do this. They neglected to tell you that there's 3 operations: combining, factoring, distributive law, and factoring. So let's take a monomial times let's say that we've got 2x. There's our monomial, and we're going to combine it with 3x plus 4. Okay? So combining means that you add. So I got a 1 here. I got a positive 1 here. To get rid of the parentheses, I distribute. So 1 times 2x is 2x. 1 times 3x is 3x. And 1 times 4 is 4. And what's the only thing you can combine there?
The 3x and the 2x.
And that's 5x plus 4. And that's how you combine polynomials. I'm doing this for a reason. I'm making sure that everybody's up to snuff before I get to factor. Okay? So let's do a subtraction. If you don't believe that combining is subtracting too, then let's do one. Alright, let's do 2x minus 3x plus 4. Same type problem. We're combining. I didn't say we're taking away or subtracting. I said we're combining. 1 goes here, 1 goes here. That's 2x. What did I distribute here? A -1. Is that important?
Yes.
Yes, very important. So you take your handy dandy highlighter and you highlight this guy right here because he's going to make life rough for you if you don't recognize him. And that's going to make a -3x. My board will put -3x minus 4. And I leave it in red because it changes everything here and here. And now when you combine those two, what are you going to get?
Negative 1x.
-1x or negative minus. So I combined and I didn't use any different rules. Now when we take our jump from combining to the distributive law, 2x, we just don't have anything between the parentheses. And we use our exponential laws because technically this is what we have. Right? And the only thing we do here is add the exponents. But students somewhere forget this. They forget that this is x to the 0 and they just sit there and stare at it. So 1 plus 1, 2 times 3 is 6x plus 4 times 2 is 8. And 0 plus 1 is, and that's your answer. Now what we're doing now is simplifying because there's no exponent. I mean, there's no equal sign. But if you put an equal sign, then we're talking about solving. Then we get. But right now, I'm just making sure everybody gets the cobwebs loose with this. Now factoring, you undo this and get this. And I'm going to wait on factoring. We're going to talk about factoring later. I just want to do a couple of equations and then we'll move up to factoring. Uh, 2x plus 3x minus 2 is equal to 0. Now this is an equation. And of course, we're talking about pre-algebra. To algebra 1, somewhere in there. And what's the first thing you're going to do? Combine like terms. And that's going to give you 5x minus 2 is equal to 0. Let's go over the main objectives of algebra. Of course, I know every one of y'all know the main objective of algebra because I know your teachers taught you that back in pre-algebra and algebra 1. That's why you remember it today. Some of y'all are going, I have no idea what he's talking about. That's why. The main objective of algebra is to find the unknown. I can't spell today. I'm just going to put a period there. Unknown variable. That's the main objective of algebra. To find out what it represents, to find out what it is, to find out what it looks like. Find out what it is, that's finding the solution. Find out what it represents, that's an inequality. In other words, the group of numbers. Find out what it looks like, that's when you graph a function. Okay? But in order to do any of those, you have to solve for the what? Variable. So your main objective is to grab that x. But when you grab that x, what's in the way? Negative 2's in the way. You reach out to grab that x, you can't reach it because negative 2's in the way. So you add 2 on both sides because you got to get rid of it. And how's the only way to pay off a debt? No, the government pays you out of it, right? And you get 5x is equal to 2. Now what? Divide by 5. And we just solved the unknown variable is 2/5. And that's an equation. Now, I've just covered everything that you need to know. Well, what about all these big, nasty? Well, you apply the same principles. Let me give you an example. Is that the same thing we just did? Mm-hmm. It's an equation. Yeah, all you got to do is combine like terms. Everything that I showed you in the little review, you can solve this. There's nothing new here. Distribute, turn this negative red. And that's a negative what? 1. Don't say 0 because 0 will take out the whole second term. So x squared. This board is not doing what I tell it to. Just like a woman. I'm sorry. X squared plus 3x plus 6 minus what?
7. That's plus 7.
Hmm?
Oh, minus 2x.
What are y'all talking about? Y'all on drugs? Minus 2x squared. I thought I was on drugs.
X plus 7.
Oh. Now, usually, after you use the distributive law, what is usually next?
Combine like terms.
Combine like terms is usually next. Now you combine like terms. What is 1x squared minus 2x squared?
Negative.
Minus 1x squared. 3x minus 3x
0.
cancels. And 6 plus 7 is?
13.
Now I'm going to bring this x squared across the river. And that'll give 13 is equal to x squared. I did this one time, and a student about had a heart attack. Why would they have a heart attack? Because of what I just did.
Because you forgot to do all the negative movement.
Yeah, that's one reason. But why? But that's not the reason she had a heart attack. Is it she?
Because it's not squared.
That ain't it. Good answer, but that ain't it. That ain't why she had a heart attack.
Is it because you moved the x to the other side?
Yes. I put the x on the right-hand side.
What?
That's unheard of. The x is supposed to go on the left-hand side. You ever had a teacher teach you that?
No.
Good. Good. Because that's like taking your kids, you got a 2-year-old, taking your 2-year-old to the park, and your 2-year-old name's Jody, and Susie is sitting over here. And that's her cousin. You take his cousin with you. And they get on the seesaw. I'm sorry, the teeter-totter. Down here, we call them seesaws, okay? But you get corrected because you're ignorant, okay? And they're called teeter-totters. I have never heard of a teeter-totter until I was corrected about 3 years ago.
Who corrected you?
A damn Yankee. Never
That
asked
was
that.
coming.
Huh?
I said I knew that was coming.
And what's the difference between a Yankee, a Northerner, and a damn Yankee?
Damn Yankee was raised in the north and lives in the south.
Yeah, but it needs to go back.
Yeah.
That's a damn Yankee. And a Yankee and a Northerner, people that move down and they're just from the
What
north.
if they're from out west?
Huh?
What if they're from
That
out
don't
west?
count.
Okay.
The only thing that counts is California, and they're damn Yankees. If you come from California.
I didn't come from
Okay.
California.
Well, then you're fine. California and Florida, they're two different
I
places.
came from Arizona.
Okay, well that don't count. You just normal. Okay. All right. So you're down in South Iowa. You go to the park down there in South Iowa, and Jody sits on the left hand side, and Susie sits on the right hand side. Well, you come to Anderson, Finley Park, and Jody wants to sit on the right hand side, and you whip him and say, no, you can't sit on the right hand side of the teeter-totter because Susie's got to sit on the right hand side of the teeter-totter. How much sense does that make?
None.
None. So if you ever had an algebra teacher tell you that you have to put x on the left hand side, you need to go up and slap him because that's stupid. Why did I put the x on the right hand side?
To show that you changed the
To make the variable what?
positive.
Which is another, this is number 1. Number 2, always try to keep variable what?
Positive.
Positive. Don't fool with dividing through by negatives because all that's going to do is cause problems. Just whenever you can, take it over to the other side. Now, why? Later on, I'll tell you why. When we get to inequalities, I'll tell you why.
Can I
Yes,
ask a
ma'am.
question? Is that why in the computer sometimes when you put in the answer if the x is negative to begin with, well, I won't take it and it'll mark it wrong if you have it on the wrong side? Or
Probably, yeah.
because I know the computer system's crazy sometimes,
Yeah.
so that's
And anytime you have a homework problem that you know you got right, or a test question that you know you got to do, see me after class and I'll change it for you. You don't have to take it over. If you know you got the right answer, then just see me after
because
class.
it only takes one answer.
Yeah.
To be.
So I'll fix it. I'll fix it for you. All right. So I took that x squared instead of dividing through by negative and all that. I just picked up the whole thing and what? Brought it over here and made it positive. And if you do that, 90% of the time it'll make your work a whole lot easier than doing all that dividing through. Because on a test, what is your 2 worst enemies? Time
Henderson.
and careless mistakes. You said it yourself. Okay, careless mistakes. What induces the other?
Careless mistakes.
The time induces the careless mistakes. Why?
Because you feel like you don't have enough time to finish
Exactly.
it, so you
What are
rush.
you going to forget? You're going to forget the little trivial things like dividing through by negative. And then when we get to inequalities, if you divide through by negative, what do you got to do to the inequality? You got to flip it. So there's two trivial rules that you don't need to remember. When all you got to remember is just keep the variable what?
Positive.
Positive. That's one rule. One rule or two rules? Which one do you want to remember? I'd rather remember one rule. 90% of the time, you can keep this variable positive by putting it on the other side. So Jody and Susie can sit on either side. So tell that teacher that told you put the X on the left-hand side that they're crazy. And X is equal to the square root of 13. Well, let's think about this. What's the square root of 9?
3,
What's the square root of 16?
4,
What's between 3 and 4?
3.5.
So all you got to figure is this, and you'll have the square root for that, and then just keep going half and half and half. It's called interpolation. It's where you take half of half of half of half until you get the number you want. So 9 to 16 is 7. Half of 7 is 3.5. 3.5 added on is square root of 12.5. Oh my gosh! 3.6. Now take the calculators out and take the square root of 13 and see what you get. Oh my gosh! It's a miracle. I did that without a calculator. What's this 6 cents for? Okay? Now you know how to. Now you can add. You can add, subtract, multiply. Why am I showing you all this? Well, let's get to the factoring. What is factoring? Factoring is division. Well, let's start off with something simple. As soon as you were in grammar school, you learned your multiplication tables. And if I was to tell you, factor 54, 90% of you would say 54 is equal to what? 6 times 9, Hubert. Yeah, that's right, class. 54 is equal to 6 times 9. And there would be one person who say, well, I think 54 is equal to 2 times 27. Okay, you're weird. All right? But that is factoring. And then you could also say that 54 is 1 times what?
54.
So I just factored 54. So the definition of factoring is expansion. Because what did I have here? What kind of